What's up, guys? This is Dominic from the Bechtel Center, and today we're going to be talking about how to do thread milling on a CNC mill. In this guide, I'm going to cover how to select the right tool and drill sizes for a given thread type, how to program the thread milling operation in Fusion, and finally verify that your thread is good to specification. We're also going to be discussing the use cases of thread milling compared to something like traditional hand tapping. Before we start, I'd like to discuss some limitations of this guide. We're only going to be covering internal threading on the mill, so for either external threads or single point threading on the lathe, you'll have to discuss it with a supervisor in the Bechtel Center for more advice. Next up, this process is only meant for straight threads. If you want to do tapered threads, you'll have to use a hand tap. Finally, this process will cover a range of the most common thread types and materials, which should be enough for most projects. But if you're making something more unique, you'll again need to talk to a supervisor. As to what exactly those permitted threads and materials are, we've prepared a table to tell you exactly that. Up here, you can see the range of the permitted thread types, and down here, you can see the acceptable materials to go down with those. The table also tells you what exact thread mill cutter you'll be using for each thread. Moving away from the limitations, thread milling is a machining process that creates threads using a specialized cutting tool called a thread mill cutter. Most of you guys are going to be familiar with tapping, which uses a tool with the exact thread shape to cut threads in one go, going straight down into the hole. Thread milling, on the other hand, is going to use a rotating cutter like this, and it's going to move in a spiral downward, creating your threads. And it also allows you for more flexibility and better chip control. Now let's talk about when to thread mill and when to hand tap. Hand tapping is usually going to be fine for softer materials like aluminum, brass, and plastics, especially if you're only making just one or two threads. For harder materials like steel and titanium, you have to keep in mind that a hand tap can break really easily, so thread milling is going to be the preferred method. If you're also doing a lot of holes, thread milling can save you a lot of time and will usually yield a better result. If you're unsure about which method to use, you can always ask one of the peer mentors in the center. Before we get to thread milling, we'll need to drill a hole that is going to be the correct size. To find what exactly the size is, we're going to type out engineer's edge, tap and drill chart. And here you're going to be able to see a wide range of the most common thread types, as well as the drill size, which is going to determine your correct internal diameter for the thread. In our case, we're going to be doing a 1/4 inch 20 thread. So our drill is going to be a number 7, which if we look up over here, it's going to be 0.201 inches in diameter. Now that we selected the correct drill size, we can go into Fusion to program our toolpath. In this video, I'm going to assume that you already know how to model your stock and model, create a setup, and probe your stock. If you're not sure how to go about doing those, we have other videos on the channels that'll help you with those. To program the drilling toolpath, you're going to go into Drill. We're going to select the machine that your machine is on. So in our case, we have 4. Going to go into Hole Making, Drilling. Material is going to be carbide. And we're going to scroll down to select the number 7. We're doing aluminum, so that's going to be N2. Hit select. In geometry, we're going to select our hole face. In heights, we're going to do drill tip through bottom. And ensure that cycle is set to rapid out. Once your hole is drilled, it's time to program the thread milling operation in Fusion. Make sure that if you did include your thread in the model, it's going to be symbolic, so model should be unchecked. The reason why we do this is that it's going to be easier to see what's happening in the simulation afterwards. Now going back to manufacture, we're going to select drill again. For our tool, we're going to go into the machine, select milling, thread mill, and here we're going to see the 4 available thread mills that we have. Now for your operation, you're going to have to go through all of these and see whichever one is going to fit your needs. In our case, it's going to be a 1/4 inch 20, and we're drilling into aluminum, so we're going to select aluminum. That's going to be it for tool. We're going to go into geometry, where we select our hole face. In heights, we're going to have a adjustment for our whole top. Point one is a good rule of thumb. And what this is going to do is it's going to make it a little easier to verify that our toolpath is correct and it's going above the hole. For our bottom height, we also want to include an offset of 50 thou would be a good rule of thumb. So we should go that or above. And what that's going to do is it's going to make sure that your tool doesn't plunge into the bottom of the hole. In cycle, we're going to go into thread milling. Threading, right-handed. If you were doing left-handed, you would to a supervisor. Direction should be climb. Pitch is going to be 1 over your TPI for imperial. So in our case, it'd be 1 over 20. If you were doing a metric pitch, then you would simply type out 1 millimeter directly, or like a M6 times 1. For your diameter, we're going to say it's going to be your major diameter, so 0.25. We're going to enable multiple steps, and we're going to select 4. For our step over, we're going to type out our major diameter minus our drill diameter. So in our case, it's going to be 0.201 for a number 7, divided by 2, because this is a radial measure, not a diametrical one, and then divide that by 4, because we have 4 step overs. I'm going to include a repeat pass, which is going to do a finishing pass and smooth out our threads. Now we can hit OK. Once you've made all your selections, you always want to verify your toolpath. First, we're going to apply a section analysis, and I'll set it by the appropriate distance. Now we're going to select the front view, select the 2 operations that we just did, and hit simulate. Here, we're going to be checking that our drilling is only going the distance that we need. And on the threading, we're going to be checking that our cutter is going to start above the whole bottom, which happened here, so that's correct. And it should always be ending above the whole top, which again is happening here. We're also checking that the step over doesn't seem too aggressive and it's going to be cutting the thread continually. Now your final cut is going to be a finishing one, so this is not going to be a visible step over. You should not be seeing any collisions at any point of this simulation. This is going to conclude the cam section guide. Now I have one final note before this video ends, and that's that once you have a reservation and come into Bechtel to mill your thread, it is advised that you bring your bolt or fitting or whatever you're doing with you so that you can test out your fit. With the settings given, it's likely that your bolt or fitting will not fit on the first try, and you will need to increase your diameter in the settings to ensure fit. So the way you go about doing that is you select the drilling, and in your diameter, you would increase that by, let's say, 1 thou. Now you'd repost that, and then you would see if it fits. If it does not, increase by 1 thou again, 1 thou again, and you're going to repeat that until your bolt fits. Be careful, the transition between the bolt not fitting and being loose, it can be as small as 2 to 3 thou. So that's going to be a very fine increment. Make sure that you don't remove the part before your fit is checked, because otherwise you will not be able to find that thread again. All right, that's going to be everything that I wanted to talk about in this guide. If you have any questions about what I discussed today, you can come into the Bechtel Center and talk to one of the metal shop peer mentors. Have a nice day, and I'll see you in the shop.